So types of sets. The first one is empty set. It is also called void set, null set. And the second one is finite set and infinite set. Next, subset. Next, power set. Then universal set. Right? So let us see what is empty set.
Sir, equivalent set.
Equal set equal.
Yes, thank you. Equal sets. Let the joins. Equivalent sets. Still any other sets to be discussed?
Sir, unequal sets.
If yes, when we discuss about equal sets, unequal sets automatically will get it. That is also one type of set. So let us see the first one. What is empty set? What is an empty set?
Sir, in a given set, the elements will be nothing, sir.
The set will be empty, sir.
How it is empty? When we'll say that the set is empty?
There will be no values.
Sir, when the elements are not present.
Yes, a set which has no elements. So this is called empty set. Can you give an example? And the empty set is denoted.
All numbers.
It is denoted by either this symbol or this symbol. We'll read it as null set, and it is read it as pronunciation is like phi, right? In Wi-Fi, like how it is phi, so the symbol is also read it as phi. Phi means it is an empty set. Can you say the example for this? The set of all numbers, all real numbers, whose square is minus 1. The set of all real numbers whose square is minus 1. If you take any real numbers whose square will get minus 1, is there any possibility? Suppose if you take negative numbers, if you make it as square, you will get positive numbers only in real numbers. So there is no element which satisfies the square of a number is -1. So it is null set, or will represent as these brackets. So set of even prime numbers more than 2. So even prime number only one we have, that is 2. More than 2 means it is also greater than 2. It is also an empty set, right? And the next one is finite set. What is finite set?
Sir, good morning, sir.
Good morning. What
The
is finite?
countable set, sir.
So it is a countable set.
Yes, the elements are countable. A set which has finite number of finite number of elements. Okay, ma, just a minute. Elements. So can you give an example for this?
Sir, 1, 2, 3, 4, 5.
So
The set of national
set
numbers.
of
Set of national numbers. 1, 2, 3, and so on. Is it a finite set or infinite set?
Sir, infinite set.
Infinite.
infinite.
Yes, till 10.
Finite set.
Finite
Ah,
set.
yes, no, finite set. Suppose set A is given set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 means it is a finite number of elements. We can count it. So if a set consists of a countable number of elements, that is called finite set. If it is uncountable number of sets, that is called infinite set. So the next one is infinite set. So infinite set is a set which has infinite number of elements. So let us take an example. Here we can write set of natural numbers. Not only set of natural numbers, we are taking one example for this. That's it. Next, what's the next one?
Subset.
Subset.
Universal set.
Which one, ma?
Universal set.
Subset, sir.
A subset. First, let us discuss about subset, and it is easy to make it understand universal set. Subset. So if you take two sets, if every element of first set is an element of the second set, so let us take two sets. Let A and B be two sets. Right? If every element of A element of A in B, element of an element of B, then A is subset of B. It is denoted by A subset of B. Let us consider an example. Suppose set A is set of 1, 2, 3, and set B is 1, 2, 3, 4, 5, 6. So every element or each element in A is an element of B. 1, 2, 3, 1, 2, 3 is exist. B may have the same number of elements or same elements or more than that. But as per the definition of subset, every element in A would be exist in B. Then we will say that A is subset of B. So it is denoted by, now here A is subset of B, isn't it? Or
Yes, sir.
Yes, sir.
we'll call this as B is superset of A. Here it is A is subset of B, or B is superset of A. In this case, both also same. Now, suppose at least one element in A does not exist in B. And the next example, suppose A is 1, 2, 3, and B is 1, 2, 4, 5, 6, 7. So every element in A, 1, 2 are exist in B, but 3 is not in B. So we will say that therefore A is not a subset of B. This is the symbol for not a subset, right?
Yes, sir.
Next. So the next one is universal set.
Sir,
Yes, ma. Power set also we'll discuss it.
sir, one doubt, sir.
Tell me.
Sir, in subset A, if A and B are equal, which is the subset of which, sir?
Very good, ma. Excellent doubt. We'll discuss it. Suppose let us take an example. A is 1, 2, 3. B is also 1, 2, 3. This is what you are asking, right, ma?
Yes, sir.
So in this case, every element in A exists in B, right? So that
Yes, sir.
we'll say A subset B. And every element in B exists in A. So that B is also subset of A. Clear, ma?
Yes, sir.
So in this case, A is subset of B, B is subset of A. If A is subset of B and B is subset of A, what you got the idea here? A and B. What can you say about A and B?
Equal.
Equal, that's it.
Equal.
So if A is subset of B and B is subset of A, then we'll say that A equal to B. So when A equal to B, what type of sets are those?
Equal, sir.
That's it. Equal sets. Equal sets. So the elements of A are in B. All elements of A are exist in B. The condition is B also should have the same elements. So based on this, we can write. Let us take two sets. Let A and B be two sets. If every element in A every element of A is in B, and every element of B is in A. Clear, ma? Then A and B are called equal sets. It is denoted by A equal to B. So based on this only I define this. A subset B means every element of A in B is in B. And the second case, every element of B is in A. So that those two sets are equal. Clear, ma? This is an example for
Yes, sir.
next.
Sir, what if the two elements are unequal, but the sum of those elements are equal? Means what they will say, sir?
I did not get it. Can you repeat?
Sir, sum of the both elements means it is a equal set, sir.
When the elements are same equal sets, the sum also will get the same only. But we'll define based on the number of elements only, not based on the sum. But you'll get the same only because both sets having the same number of elements. Same elements, not only number of elements. Right?
Yes, sir.
Next. Equivalent sets. Anyhow, we discussed about equal sets. Let us see equivalent sets. So here, number of elements are same, but the elements need not be the same. So before going to discuss about equivalent sets, let us discuss about cardinal number of set. So if we discuss about cardinal number of set, cardinal number of set in the sense, if set A consists of 3 elements, the number of elements of a set is called cardinal number of set. Clear? The number of elements of a set is called cardinal number of set. The cardinal number of set is denoted by n of the set. So number of elements of A. How many are there here?
3.
3. So the cardinal number of set is 3. Suppose let us take another example. P, Q, R, S. So what is the cardinal number of set B?
3.
4. P,
4, sir.
R, S. 4 elements are there. Now we can easily define the equivalent sets. So let A and B be 2 sets. If n of A equal to n of B, then A and B are called equivalent sets. Right? If you take, for example, here only C equal to PQR. What's the cardinal number of set C? PQR, 3 elements only.
3.
Here n of A, cardinal number of set A and cardinal number of set C are same. So that A and C are called equivalent sets. In this example, A and C are equivalent sets. Clear, ma? If you see the difference between
Yes, sir.
equal sets and equivalent sets, equivalent sets, the number of elements only same. Elements may be differ. Whereas come to equal sets, Number of elements are same as well as the number of elements as well as elements also same. Then they are called equal sets. Is it clear?
Yes.
Yes, sir.
Next, we'll go to subset over, I think so. Next, universal set. Suppose we'll define this easily by taking the example. Suppose let us take A is 1 2 1 2 3 4. Set of 1 is it a subset of set A or not?
Yes, sir.
So set of 1 exists in A, so it is a subset. Set of 2 is also subset. Set
Yes,
of
sir.
3 is also subset. Set 4 is also subset. Set 1 2 1 3,
Yes.
we should write set only. Next 1 4, next 2 3 2 4 and 3 4. Well, these are all subsets of set here, right? So in this case, we'll say that A is a universal set of these sets. In this case, set A is universal set of these sets, right? You may think that's a 3 4 we have written. Why can't we write 4 3? This is also one more set. 3 4, a set of 3 4 and set of 4 3 are same. Since the order of elements are immaterial in set, so set of 3 4 we can write it as set of 4 3. But whereas come to ordered pairs, set of 3 4 and 4 3 are not equal, right? Do you understand it?
Yes, sir.
And the next one is, go to the power set. So we have written all possibilities, all subsets of set A. So power set is set of all subsets of a given set. Set of all subsets of a given set. That is called power set. Let us write this power set. Before going to write the power set, we should note that the first note is phi, empty set. Empty set is a subset of every set. And the other one is every set is subset of itself. So while considering number of sets, we should take set of all these we have to write along with phi null set. Set 1, 2, 3, 4, set of 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, set of 2, 4, and set of 3, 4. We should use this bracket only. And the set itself 1 2 3 4 is also subset. So we have taken all the subsets and we made it as set. So set of all subsets of a given set is called power set. Right? Thirdly, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But still we can write if there is a possible to write the other sets, we have to write it subsets. One, two, three, set of 1, 2, 3, next set of 1 to 4, and then set of 2, 3, 4. So totally how many are there now?
15, sir.
15. So one more will get it now. So other one is 1, 3, 4. So if you see that the total number of subsets, we got it as 16. So here we can use this formula to find the number of subsets of a set containing n elements is 2 power n formula. Suppose n is number of elements in a set. In this case, we have taken a is 1, 2, 3, 4. So cardinal number is n of a is 4, right? So substitute in this formula. We'll get 2 to the power of, here I am going to write 4. So 16. We got 14 subsets. That's it. Even number of elements in power set also contains same 2 power n only. So power set is denoted by P of A. Right? There are two more. One is proper set. And one more is a singleton set. That's it. If we discuss this, it's going to be complete. So proper subsets is if you take, suppose set A is 1, 2, 3, 4, right? We have written all the possibilities. Let us, for our convenience, let us take 1, 2. So the subsets are 5, set of 1, set of 2, and set of 1 to usually. Accept the same set, man. If you consider the other sets, subsets, so these are called proper sets. Proper set in the sense we will exclude the same subset. That's it. The remaining all subsets we have to write. And the next one is singleton set. What is meant by a singleton set? A set which consists of unique element or only one element, then it is called singleton set. For example, set of even prime numbers. Set of even prime numbers is only 2, right? So this is called singleton set. Clear, ma? Do you understand it?
Yes,
Yes,
sir.
sir.